Hello engineers, welcome back. In the previous video, we learned a new technique called prefix sum. In this video, we're going to solve a lead code question based on this technique. Let's get started. So this is the question we're going to solve today. It's called find pivot index. Let's understand the question. Let's see how we can approach this and then we will code it out. Okay. So this is the question. Given an array of integers, calculate the pivot index of this array. The pivot index is the index where the sum of all numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. If the index on the left edge of the array is on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index. If no such index exists, return -1. Okay. So this is our question. So let's try to understand this with this example. So this is the array 173656 and here the returned index value is 3. So the index is 0 indexed array, so 0 1 2 3. So this is what they have returned, and the explanation is left sum, the left sum of this index. So whatever is available to the left side of this index, that is the left sum, and whatever is available on the right side of the index, that is the right sum. So the left sum is nums of 0 1 2, which is 11, and the right sum is 5 plus 6, which is 11. So 11 equals 11, so they have written index 3. Okay, and in this example there is no such case where the condition is satisfied, so the output is -1. Okay, so let's take this array, let's try to build our logic. Let's go to our whiteboard. 173656. So if this is our array 173656, so as always we'll try to break the problem into smaller parts and then we'll combine it. Okay, so what do we need? We need to return an index. So let's say we have an index called pivot index. This will be our return value, and they said if you do not find any matching index that satisfies the condition, you should return -1. So we will assume that there is no index to begin with which satisfies the condition, and we will simply return -1. Okay, and then going back to the question, what do we need to do? We need to check if the left sum is equal to right sum. So we need these two trackers, and we will build them and compare them. So we will need two trackers. Left sum, let's call it equal to 0 for now, and we need right sum, we'll equate it to 0. We don't need to equate it to 0, but just for initializing, I'm just equating them to 0. We will change it if required. And pivot index, left sum, right sum. I think we got all the trackers in place. Now here we are talking about sum everywhere. Sum. So there is left sum, there is right sum. So whenever we are dealing with sum of elements within the array, now we know that we have a technique called pivot index. Sorry, prefix sum. So we can make use of prefix sum so that we don't have to calculate left sum as we iterate through the array every time. We don't have to calculate the right sum for every index. So we can make use of the prefix sum. So we will build a prefix sum initially and then we will make use of it. So we will need a vector in int. We'll call it prefix sum and we'll build it. Once we have prefix sum, we just try to build a logic where we will use this prefix sum to calculate the left sum and the right sum, and we just need to compare them. If left equal to right, we will find our pivot index. That's it. So first let's build our prefix sum. So how do we build our prefix sum array? So we know that the first element in the prefix sum is equal to the first element of the array, so we can directly do that. So prefix sum dot pushback nums of 0. So this is the first element. So how will our prefix sum look like in the end? if this is our prefix sum array, so the first element is known, which is nums of 0, which is 1. Okay. So the second element will be the sum of this one plus the new element, 7. So the new element is 8. And the third element will be sum of this element plus the new element. This is 3. So 8 plus 3, 11. And so on. 11 plus 6, 17. 17 plus 5, 22. 22 plus 6, 28. So this is the prefix sum vector array. This will be the final one. So how do we build this? We will simply have a while loop or a for loop. Let's use a for loop. Int I equal to 1, because we already have calculated for 0. We need to start at 1. I less than nums of size, I plus plus, and we simply push back. Prefix sum dot pushback. So how do we get this? First, we get the previous element of the prefix sum. I minus 1. And we will simply add the new element from the main array, nums of I. So that's how we will get our prefix sum vector. So that is done. Now we can iterate over the main vector and build these values, left sum, right sum, and we will compare. If they are equal, then we will find our pivot index. Simple. So let's start our new loop for int I equal to 0, I less than nums dot size, I plus plus. Okay. So what do we do here? So our main logic is something like this. Main logic is something like this. If left sum equal to right sum, then we found a pivot index. So pivot index equal to I, and we have found our answer, so we don't need to continue the loop. We can simply break from here. Okay, and that's it. We will need to return our pivot index in the end. Now the remaining piece is how do we get left sum and right sum. So that's all we need to do. Let's try to do that. So that's it. That is our main logic. How do we use the prefix sum to get left sum and right sum? Okay. So left sum. So if we go back to the question, they said if the index is on the left edge of the array, then the left sum is 0. Okay. So now we are at index I equal to 0. I equal to 0 is here. So these are my indexes. So I is 0. So this is at the left edge. So there is nothing to the left of this. So the left sum at this point is 0. So we will add this condition. If I equal to 0, then left sum equal to 0. Else if the I is not at 0, if let's say the I is at 2, for example, so what is the left sum? Left sum is the sum of all these two, all the elements to the left of it. So sum of these two. So we need 7 plus 1, 8. Now we don't need to calculate this again because we already have our friend prefix sum. So we just need to get the value from the prefix sum. So we know how to do range based queries on prefix sum. So here what are we asking? We are asking, give me the sum of elements from 0 to I minus 1, right? So 0 to I minus 1. So I is at 2. So 0 to I minus 1 becomes, if 0, these are the indexes on the prefix sum, I minus 1 is here. So this one will carry the sum of all elements up to ith point, right? So we can use that. So left sum equal to prefix sum of I minus 1. So this is the sum of first element up to I. Okay. So that is my left sum. So how do we get the right sum? Okay. So how do we get the right sum? For the right sum also there is a condition in the question. This also applies to the right edge of the array. So when the index is at the rightmost edge, when the index is at the last element, there is nothing else to calculate on the right. So at that point, the right sum will become 0. So let's take that condition into consideration. If I equal to nums dot size minus 1, then right sum equal to 0. Otherwise, we can get the right sum from the prefix index, prefix sum. So how do we do that? So if my index is at 2, the right sum will become the sum of all these three elements, right? So we know how to do range-based queries on the prefix sum. So if this is my uh, range, so 3, we need to get the sum of index 3 to 5. So how do we do that? We ask prefix sum of the last element in the range minus prefix sum of n minus 1. So prefix sum of 2. So that is how we get the prefix sum of a range. So what is prefix sum of 5? It is 28. And what is prefix sum of 2? This is 11. So 28 minus 11 will become 17. So is that what it is? Let's see. 6 plus 5, 11, 11 plus 6, 17. So we got our answer. So we can use this logic. Right sum is prefix sum of the last element nums dot size minus 1 minus prefix sum of I. We can directly use I. So we got our right sum, and that's it. So we got our left sum, we got our right sum. We will compare. If left sum equal to right sum, we would have found our pivot index and break. Okay, so this is our logic. So let's do a dry run so that we can check if our logic is correct. So what are our trackers? We have our pointer I, which is moving across the array, and then we have left sum, which is currently at 0. We have our right sum, which is currently at 0, and then we have our pivot index, which is currently at minus 1. Okay, and we start our loop. So I is at 0, and left sum will be 0 because we are at the left edge, and right sum. So what is the logic for right sum? Right sum is prefix sum of nums dot size minus 1 minus prefix sum of I. So prefix sum of nums of sides minus 1. So this is the last element. So 28 minus prefix sum of I. I is 0. Prefix sum of 0 is 1. So this is 27. So our right sum is 27. Let's verify. So we are here at 0th index. Our right sum is sum of all these elements. So let's see, 7 plus 3, 10, 10 plus 6, 16, 16 plus 1, 20, 16 plus 5, 21, 21 plus 6, 27. So this is correct. So our logic is working. Now we are checking, is left sum equal to right sum? No. So our pivot index will remain at minus 1. And we move the I pointer forward. Now, what is the left sum? Left sum is prefix sum of I minus 1. So I is 1, I minus 1 is 0, prefix sum of 0 is 1. So left sum is 1. And what will be the right sum? Right sum is the last element minus prefix sum of I. So the last element is 28 minus prefix sum of I, 8. So this is 20. So let's verify. So we are here, I is at the first position, and we need the sum of these 4 elements. So let's see, 3 plus 6, 9, 9 plus 5, 14, 14 plus 6, 20. So this is correct. So our logic is fine. So again, we will check left sum equal to right sum, which is not equal. So pivot index remains at -1. And let's move our I pointer. Now I pointer is at 2. And what will be the left sum? Left sum is prefix sum of I minus 1. I minus 1 is 1. Prefix sum of 1 is 8. And what will be the right sum? Right sum will be last element minus prefix sum of I. I is 2, so this is 11. So 28 minus 11, that will become 17. So our right sum is 17. So again, left sum is not equal to right sum. Pivot index is still -1. And I moves forward. So what will be our left index? Left index will become a prefix sum of I minus 1. So this is 2. And left sum is 11. And what will be the right sum? Right sum is last element minus I, prefix sum of I. I is 3. So prefix sum of 3 is 17. And this is 11. So right sum is 11. So at this point we have found left sum equal to right sum. So our pivot index is I. So I is 3. So once we find our pivot index, what did we say? We say pivot index equal to I, and then we break. So we break here and we will return pivot index. So pivot index is 3. So that is our answer. Okay. So our logic seems to be fine. Let's go to Leet code and code it. Okay, so we are at Leet code now. So what are our trackers? We need a left sum, which can be 0. We need our right sum, which can also be 0. And we need a pivot index, which is -1 to begin with, assuming we don't have any pivot indexes in the vector. And we will build our prefix sum. Okay. Okay, let's start building our prefix sum. So as we know, the first element is a direct pushback, which is the first element from the main array. So that is done. And then we can use a for loop to fill out the rest. Int I equal to 1, I less than nums dot size I plus plus, and we simply add the new elements to the prefix sum. So how do we do that? Prefix sum of the previous element. Previous element is I minus 1, and we add the new element, which is nums of I. So this is how we build our prefix sum. Now our prefix sum is ready. Now we can find our pivot index. So let's start another loop, this time at 0. I plus plus. And what do we need? We will check if left sum equal to right sum. Then we found our pivot index and we break, and then we simply return our pivot index. So how do we build the pivot index? How do we build the left sum and right sum? So our first condition is if I equal to 0, then my left sum equal to 0. Otherwise, my left sum is prefix sum of I minus 1. Prefix sum of I minus 1. And there is a condition for the right sum. If I equal to nums dot size minus 1, which means this is the last element, then my right sum will become 0. Otherwise, my right sum will become prefix sum of I last element, right? Nums dot size minus 1 minus prefix sum of I. I think that's what we did here. Prefix sum of nums dot size minus 1 and prefix sum of I. That's it. So I think that's it. Let's try to run and see. Yeah, I think we did everything right. Let's submit. And it is solved. So imagine if we didn't use prefix sum, we would have used some inner loops to calculate the left sum for every I, and use some other loop to calculate the right sum for every I, and that would be inefficient. So making use of a prefix sum gives us an advantage in terms of time complexity. Even though we requested for additional space and we pushed some elements into this additional space, so what will be the size of this prefix sum? It will be the same size of nums. So this is in correlation with the size of the input vector. So the space complexity is n here, but the time complexity has reduced from probably of n square to O of n. So we have reduced our time complexity using prefix sum. So that's how we can optimize our code and algorithm using this prefix sum technique. Okay. So if you have any questions, you can definitely ask me. That is it from this video, guys. Thank you so much for watching. Please do leave a like and do subscribe to the channel. Please bookmark the playlist and share it with your friends. I will see you in the next one. Thank you. Cheers.